we are going to use a database. And in the database, we have customer table. Okay, this is a customer table. Okay, we are going to have like organization table. Okay, but customer table is main important. So this customer table will have the fields like customer ID, customer first name, customer last name, next phone number. Okay, these are the different, these are the columns in the table. Okay, these are the columns of this customer table. So these are the columns. Now, when I write a Java class, and in that I have a business method, I add customer. Okay, when I say business method, I add customer. Now here I will have a logic. Here I will have a logic to add customer data in the customer table data. In the customer table database, in database. And what are the logic? Can anyone tell how you will add this logic? What is the logic you will add here to connect to database? You might have studied this in your advanced Java. What is the logic that you will add? I mean, how you will connect from Java program to a database? How will you connect? Yes, JDBC. Yes. So using JDBC, yes, using JDBC, we will connect to this. Okay, but now I am not going to write. Now I'm not going to write any business method connecting to the database. Okay, because my focus is to write the unit test code. Okay, now I'm not going to write any JDBC code or anything. Okay, but you might ask, sir, if you're not going to write JDBC, then how we are storing the data in this table? That's why I'll not use the database. So in place of database, what I'll do is, can anyone tell what is a simple way to store data in Java without using database? This is one very important question. Okay, in interviews, this is the one question. What is a simple way to store data from Java program? What is a simple way to store data from Java program without using database? If you are not using database, then no need of JDBC. Then what is a simple way to store data from Java program? What is a simple way to store data from Java program without using database? Okay, one we can use MongoDB and there's a database, right? Yeah, one we can use flat files. What is another way? Java collections. Right? Okay. So in this, I'm going to use Java collections and write this method. So this add customer, instead of connecting to the database and adding the customer data, I'll use Java collections. So in this demo, so we will use Java collections to store customer data. Okay. So we're going to use this. So then you might ask a question. These Java collections are recommended in, if Java collections are there, why we are using databases? Because simple way I told you, right? If Java collections are there, then why we are using databases? Anyone can tell? Anyone can tell? Okay. See, let me tell you the basic model, computer model. Okay. So you can think like this. Say, here you have your hard disk. Here you have your RAM. That is main memory, which is also called RAM. Okay. And here you have CPU. Here you have CPU. Okay. Okay. In main memory RAM, when you install Java and when you run the Java program, in main memory RAM, your JVM, Java Virtual Machine, is launched. Java Virtual Machine is launched in the RAM. That is your main memory. Okay. So if I take RAM separately, in that RAM, so some memory will be occupied by your JVM, Java Virtual Machine. Okay. And inside Java Virtual Machine, you have in JVM again, you'll have certain blocks. So this block is called heap. This block is called heap. And this heap will store all the Java objects created. Heap will store all the Java objects created. That means in a program, if you use, I'm using like this. Okay. A equal to new A. That is object of A. B equal to new B. So that is object of B. Okay. So these objects will be stored in the, all the objects will be stored in the. So similarly, collections, your collections also are objects. Your Java collections also objects. They are also stored in the heap. So the data that is present in the collections, that also will be stored in the heap. So your collections also will be stored in the heap. Collections also stored in the heap. Okay. Now, the data, what will happen is, your data that is stored in the, since JVM is part of RAM, finally your data that is stored in the memory will be taken to a CPU, and in CPU the process of execution will happen. All your logic execution and all that calculations, everything will happen in CPU, right? So the data that is retrieved from main memory is faster. Your hard disk also contains data. Your RAM contains, your main memory contains data, your hard disk also contains data. But the data that is fetched from your hard disk to CPU is slow. But the data that is fetched from your main memory to CPU is fast. Okay. So that's why always when you write program, suppose you are in your hard disk, you will be storing a.java. You are writing a program and storing in your a.java in C drive. Okay. Now when you run the Java program, you compile the program, even the compiled program also will be stored in hard disk, like with a.class. When you run the Java program, that program will be loaded to your main memory, and from that main memory, whatever the data that is there with the program, that will be loaded to CPU and the process gets executed. Because in main memory, once you run the Java program, JVM is launched. Your Java virtual machine is launched, and in the Java virtual machine, you will have heap, where heap will store all the Java updates. Your collections also stored in the heap. But one disadvantage of RAM is your data in the RAM is volatile. Okay, data stored in the RAM. Data stored in RAM is temporary. That means once you switch off the computer, or once the JVM gets shut down, okay, or the system gets restarted, so the data in the memory, in the main memory, is lost. So when the JVM gets shut down, when your Java program gets completed, execution completes, your JVM gets shut down. Okay, at the time, or whenever your Java program is running and your system got shut down, then also the data in the RAM will be lost. Okay, that means the data that you store in the collections will be lost. They will not be stored permanently. Only during the execution of that program only you can use that. Okay, RAM. So data in the RAM can be used. Data in the RAM can be used only during the program execution. So once the program completes, once the program execution completes, so data in RAM cannot be used. Okay, that means suppose I want to see the data tomorrow, or I want to see the data day after tomorrow. The data will not be there in the RAM. Okay, so for that, but data in hard disk will be permanent. Okay, so data in hard disk will be permanent. Is permanent. So that's why when you set up databases, your data will be stored in hard disk. Okay, so once you install database like MySQL, or Oracle, so what will happen is the data that you store in this database, so internally the data will be stored in hard disk. So internally the data will be stored in hard disk. And how the data will be stored? Your hard disk only can store files only. So data is stored in files. So data is stored in files. So now, since hard disk data is permanent, so that's why data in the database is always permanent. So even if you switch off the database and restart, database is also a system. So if you switch off the database and start, still the data will be there in hard disk. It is like your laptop. You switch off your laptop, still your data, switch on the laptop again, your data will be there in your C drive and D drive, right? The same way here also. So that is why That is why we prefer databases in the real-time scenarios. Okay. Well, so we can store data in collections, but only temporary. Data in collections will be stored only during the program executions, because the data from main memory or RAM is faster. That's why we store for temporary. Okay, but for permanently we'll store the data in hard disk. Okay. Now what I'm going to do is, but for this demo, I'm going to write. I'm going to use Java collections to store customer data from data rather than database. Okay, fine then. Okay then. So now let me now create a Maven project. No? Fine. Again, I'm seeing just like how I created this project. I'll create one more project here. File, new, Maven project. Okay. Again, you have to select this template, quick start. Click on next. Now it will be JUnit demo 2. Okay. And then I will just click on finish. Okay. So group ID, artifact ID, package. This is your Java package. Okay. Group ID, artifact ID, version. These three, I'll tell you when I explain you Maven tool. But for now, this is the project ID. This is the project ID. Okay. So click on finish now. Now JUnit demo 2 got created. Now, if you see here again, it is showing 1.5. Again, I have to change to 1.8, right? Right click on this, properties, Java build path, right? Yesterday we have seen. Okay, right click on this, go to here properties, go to here Java build path, remove this 1.5. Now click on add library, click on JRE system library. Now select this 1.8, right? This 1.8. Okay, click on finish. Click on apply. Now select Java compiler. First Java build path you have to select, next Java compiler. Go to Java compiler. Now in place of 1.5, you have to select 1.8. Compiler is 1.8. Now click on apply. Yes, apply and close. That's all you see. It has been changed to 1.8. Okay. Again, right. See, again I'm showing. Yesterday already I showed properties, Java build path. See, you have to, if 1.5 is there, select here and click on remove. There is a remove here. You can click on remove and then click on add library. Click on JRE system library. Select this JDK 1.8. Okay. And then Java compiler, select 1.8. So Java build path and Java compiler, these two. Okay. Now again, you see Maven has generated a project structure for us. Same SRC main Java, SRC test Java. Here you can see a package has been generated, com.junit demo 2. And how we got this package? This package, when I clicked on Maven project, here I have given that package. So that package, whatever the package that I gave, with that package it got generated. And it has generated a hello world program also. But we don't want hello world program, right? We want further more. So we can create new files, we can add, but we got a basic project structure. And also we got pom.xml. Okay, this I explained to you yesterday. So we don't want to use this version, 3 version, JUnit 5 we need to add actually. Okay. So every time you don't need to remember, right? Go to your old project, copy this dependency in the new project also. Because every time we don't want to type manually. Just copy this. Now you see 5.7. Okay, fine. Now first let us write the business method here. First let me now write, first I'll create, see what I'm going to do. What is my requirement? I'm going to add customer data. So for that, I need to create a customer class. Okay. So new class customer. So what are the different properties in the customer? Customer ID, first name. Customer ID. Okay. So this is one property, okay, which is of type string, and always the property should be private and method should be public. That is what encapsulation tells, right? Right. So next, private string first name. Next, private string last name. Next, I'll say private string phone number. Okay. Let me now generate setters and getters. Okay, generate. Now you see, for every property, there is one set method and there is one get method. Okay, how? Why there should be one set get method? Why there should one get method? I'll tell you. So this is what encapsulation. Okay, this is what encapsulation. Okay, I'm not going to tell core Java for you, but I'm just giving you idea. See, let us take phone number. Okay, if I visualize this class, if I visualize this class, okay, if I visualize this class, if I visualize this class, now you see, these are the properties. Okay, so that means you can think like this when you create an object of this class. So an object will be stored in your memory, which I told you earlier. Say this is your customer object. How I'll create an object? I say like this, right? How will I create an object? Customer C is equal to new customer. So when I create an object, so in your memory, in your heap, in your Java heap memory, which is in your JVM, there will be one customer object created. There will be one customer object created C, and this is your customer object. In this customer object, what are the properties? These are the properties. These are the private properties. Customer ID, first name, last name, phone number. So initially these values are empty. So when first time the object is created, so these values are empty. Okay. Okay. When we create an object with the default constructor, or when we create an object, we can say like this. When we create an object, so the properties are empty now. Empty now. Empty values. Now in order to pass the values, so for that what I do, suppose I want to pass phone number. How I'll do? I'll do like this: C dot set to phone number. I pass some phone number, something like this. So set to phone number is a set phone number if you take, okay. Set phone number if I take, so this is the method. This is a public method. So this is a public method. So public method I can call from outside the class. See, this is in some other class. I'm writing this code. Okay, this is in app.java something. And this is your customer.java. Okay, from outside the class, we can call the public methods. And when I pass this phone number, this value will be passed here. And this value, whatever this value, that will be coming here, the same variable. And I'm assigning to this dot phone number. What is your this dot phone number? Your customer property. That means this one. Now this will be assigned with this value. That means phone number now will be given with this value. Now if you see here, why we are calling method, you might ask, like, you can make these properties public. Say in place of private, you can make these public properties. Like suppose if I make like this, class customer, if I have like this public string customer ID, next public string phone number. Okay, instead of private properties, if I make public, then directly from outside I can access this properties from from outside class itself. I can write like this, right? Instead of writing the method, instead of writing this, calling this method, I can say like this, right? C dot phone number is equal to something like 8, something. I can give like this, right? But this is not recommended according to our OOPS concepts, encapsulation. In your OOPS concepts, you might have studied about abstraction, encapsulation. So this is not recommended in encapsulation. This is not recommended in encapsulation. Recommended in encapsulation. So encapsulation tells that properties should be private, methods should be public. Why means with this you'll have security. Because of this you'll have security. Why security? I'll tell you. Suppose imagine you take phone number which is public. From my app.java, I can pass like this also, right? C dot phone number is equal to some garbage values, some junk values I can pass. But is this phone number valid number if I pass like this? No, right? So that means you can pass any junk value also to the properties. So which should be avoided. So that's why if you pass through methods, okay, here you can have some logic. See, if you pass through methods, so here you can have some logic, like here you can have some logic. Public void set to phone number of string phone number. Okay, and I'll say if phone number, I can have logic like dot length, okay, less than equal to 10. And also I can have also check like phone number all strings. I can have some more validations. Only then I'll say this dot phone number equal to phone number. You can have security checks. You can have invalid checks, everything in the method. That's why now when you call set phone number from this method, and even if you pass this junk value, So now this logic, if condition will validate if this is correct phone number or not, and it will insert. But when you assign directly to the property, you cannot validate this. But in a method, you can write a logic to validate. So that is the reason your methods should be private. Your methods should be private so that they cannot be accessed from outside. If the methods are, sorry, not methods, the properties should be private. So the properties should be private. So if you make the properties as private so that no one can access from outside, but the method should be public. So this is what encapsulation is. Okay. Okay. So that is what for every property you have one set method where you can actually set the, you can write the value, and get property where you can read the value. Where you can read the value, that is get property, where you can write the value, that is set property. Okay. So this is your customer dot job. Okay, this is your customer dot job. Okay. Now let me write now one class, new class, customer manager. So here, now I will have no business logic. Where we can add customers. So as I told you, I am not going to use a database to store the customer data. I am going to use just collections, Java collections. I am going to store that. So for that, the best way to store collection is I'll use hash map. I will use hash map. So I'll say private map string customer. So I'll say customer list. So I'll store all the customer data in the hash map. And hash map is a key value pair. String customer. So this is the Java collection or hash map that stores the customer data. Instead of database, we'll use the map as a database. Okay, temporary database that stores the customer data. In this demo, we are going to use hash map as temporary database. Okay. Now we will add now customer data to hash map. We will write method now. I'll just say public customer, add customer. Okay, I'm going to add customer. In that, what I'll do, I'll just pass ID, first name, last name, next phone number. Okay, I'm going to pass these values. Then what I do, I create an object here. Okay. Now this is a method where I'm going to add. So this method will be called from outside. Where from outside I'll pass all these values. And in this method, I'm going to write a logic where I can store this data in the hash map. So for that, what I do, I create an object called customer. Okay. Then I'll say customer dot set customer ID, and I'll take this ID value. Similarly, customer dot set first name, and I'll take this first name value. Next, customer dot set last name, I'll take this last name value. Then I'll say customer dot set phone number, I take this, whatever the phone number value that is passed. These are variables. Okay. Now, what I want to do is, what I'll do is, now before adding this customer data to the hash map, I have to check whether customer is already, see, for example, in my hash map, how my hash map is going to store? It is going to store in a key value pair, your hash map. This is going to store with a key value pair. Okay. So this is your key. What is your key? In this, the key is your customer ID. Customer ID is the key. Key is the customer ID. And what is the value? Your value is the customer object. Okay. Now, now this is the code now. This is the code. Okay, this is the code. And now, say, for example, I pass ID value as, say, 20. Now that means before adding this ID value, before adding this customer to the map, I'll check that whether there is any key first before adding this customer data to the hash map. So we will check that if the hash map already has the key customer ID, because this is to prevent duplicates. Okay, this is to prevent duplicates. Suppose if ID 20 is not there, then we will add 20 to here, and then we will add the customer object here, your customer object. And this customer object contains all your first name, whatever you pass, the first name, last name, phone number, everything will be here. So that is the reason we will check now. Before adding to the hash map, we will check now if customer already exists. Okay. And I'll pass this customer. I'll write a method here. Okay. Check if customer already exists. Okay. Then customer list dot. Okay. Let me do like this. So customer already exists. So I can just say, I'll say Boolean exists. Okay. Then I'll say if not exists. If not exists, then I will add this to customer list dot put of ID comma customer. That means if customer doesn't exist only, if customer ID does not exist in the hash map only, we will add it. Why we are doing this check? To prevent the duplicates. Okay. I'll again explain you with the flow again. Now write this method now. So this is a private method. So what I'll do is private Boolean. It returns a Boolean. I'll say customer. I'll say, okay. I'll say if customer list dot contains key of customer dot get ID. Then I'll say return true. Otherwise return false. What I'm doing, if the hash map contains key with this customer ID, I'm returning true, otherwise false. Now that will go here. Yes, if not exists only, I'm adding in the map. Okay, that's what it does. See now, and here I'll say return customer. Okay, now you see. So for example, now let me explain you this flow once again. So what I'll do is here, let me explain this one. Okay, remove all this. Okay, remove this. Now I'm going to now in my app.java. Okay, I'm going to write like this. Okay, I'm not going to write complete program like this. I'll say customer manager. So manager is equal to new customer manager, right? Then I'll say manager dot add customer. Now I'm going to pass 100, first name as Kiran, second last name as Kumar, phone number as some number. I'm going to call this. Similarly, I'm going to pass another, I'm going to call another second time with different ID, 101. Then Ramesh Babu with some different number. Again, I'm going to call 102. Okay. Pradeep Kumar. Something I'll give some number. Okay. Now, sometimes again, I call the fourth time the same data I'm going to pass. Okay. Now you see how this is going to happen. So when I first create this object, that means this object. So this map is created. Okay, this is a global instance variable. So a map is created in your memory. And what is the ID of that map? Customer list, the reference. And this contains key value P. Now I'm calling this method add customer. If I call add customer, your ID is 100. Whatever you pass here, your ID will be 100. Okay, next is your first name will be Kiran. Okay, this data. Kumar will be your last name. And this phone number will be this one. So these values will be taken here. And now you are creating an object now. So you are creating an object. In this object, you are setting your ID, first name, last name, phone number. So you are creating an object. So in this, you are passing. Okay, let me. So here you are passing ID 100, first name Kiran, last name Kumar, phone number. Okay, whatever you pass here. Okay, that. Now then, what you are doing is after setting all these, then check if customer already exists of customer. Now it will go to this method. So that object, whatever this object is, that will go here. Now it will check in the map, customer list map contains key of customer dot get customer ID. What is your customer ID? 100, right? Now it will check whether 100 is present in this map. No. So that means it is false. So it will go here. So exist will be false. So if exist is false means, if not false means true. Here exist is false. So not false means true. That means if true, that means it will go to this method. Exist is false here. Now when I say not exist means not false, that is true. So it will go to here. Now it will add in this method. What is ID? 100. 100. And what is the value? The customer object. That means this object. So this object. And this is the key. Now second call. This is the first call, right? Second call. So again 101 Ramesh Babu, okay? An object is created again. So again this method is called. So again a new customer object is created. Okay, with ID 101, first name Ramesh, last name Babu, okay, phone number, okay, whatever the number that you pass. Now again it will check if customer already exists of customer. Now it will go here. Customer list dot contains of get customer dot get. What is customer ID here in this call? 101. It will see whether 101 is present in this. No, 100 is present, but not 101. So it returns false. So that means it will not go to true, it will go to false. Now it will come back here. Your exist is false. If not exist means if not false, true. Then customer list dot put of ID. What is your ID? 101. 101. And what is the value? This object, right? Value is this object, right? Now, again, third call. 2 calls are done, 2 entries are added. Now, third call. Now, 102. Again, third call means again it will call this method. Again, a new customer object is created. Okay, all these values are passed, first name, last name. So that is ID is 102. First name is Pradeep. Last name Kumar. Okay, phone number and all this. Now it will check now if customer already exists. Now what is your customer ID here? 102. Is 102 present here? No. 100 and 101 are present. 102. So return false. So if not false, true. So it will add here. Okay, 102. And this value is this. Now fourth call. Fourth call. Again, a new customer object is created. Okay, again it will call this. Okay, again a new customer object is created. Okay, all these values, customer ID, first name, last name, all will be passed. All will be set. ID 100, first name, last name, and phone number, whatever. Now it will check if customer already. So it will call here. What is your customer ID? 100, right? 100. Now if customer list contains key 100, yes, true. Already there is an entry with 100. So it will return true. It will go to here, exist is true. If not true, false. That means this block will not get executed. If not true, false means it will not get executed. So that means this object, this value is not added here. So why we are now adding this method? To prevent duplicate values, we are adding this method. Okay, this is how that flow takes place. Okay, so fine. So what we'll do is tomorrow we'll continue. tomorrow we'll continue. Okay. So we have written the business method now. We have to write the unit test methods for this. We have to write the unit test code for this. Okay. First we are completing the business methods. Then with using JUnit, we need to write the unit test methods. Google Classroom link. Okay. Sorry. Today I forgot. Tomorrow I will upload the Google Classroom link. Everyone understood today's program? Everyone understood today's program? Whatever I told? This program? Okay. Fine. So previous videos also I have to get from the admin. Okay. So what I'll do is tomorrow I'll share you the previous videos, if any are there, and then on Google Classroom link also I'll share you by tomorrow. Okay. So tomorrow we will continue. Sure. Yeah, this is for full stack Java students only. Okay, this is for full stack Java students only. All right then. Okay, thank you very much. Okay, thank you all. Thank you. So tomorrow I'm going to continue this. Okay. So I think okay, so Rahman, actually I think you can discontinue from this chart, I think. I think this is not DevOps course. This is not DevOps course. This is DevSecOps tools. Okay, DevOps course, you can join other course. Okay, there is other batch going on, you can join them. Okay. What is that you have? What is that? How to solve a problem? What is that? I did not understand you. Akash, solve. Maven project. Maven. What is that error? Just paste me. So you have to use the Eclipse latest version. Eclipse latest version with JDK 1.8 installed. Akash, solve. Okay. No, why interactively archetype? Just if you select here, file, new, Maven project, click on next, quick start, next. Here you can give group ID and all that. See, here you can select archetype, quick start. Directly you can select it, and you can give here this one. Use this version 202203. What is your version? 20212. It is more latest. You have to see actually. See directly you can open this and create it. I'm not sure why it is taking more time. Might be you have to see that your system RAM, memory, and all that. See, generally, if you create Maven project, quickly it will do. No, this part of your Eclipse. Okay. All right then. Yeah, business methods means class development. Yes, logic, your actual requirement. All right then. Okay then. Thank you all. Okay. Okay then. Thank you all. See you tomorrow.